Imagine standing before a mirror so vast, so perfect, that it doesn't just reflect your image, it reflects time itself. Not your face. Not the world around you. But the very first sparks of existence, the moment the universe opened its eyes. This is the mirror the James Webb Space Telescope has built for us, not of glass, but of gold-plated precision, floating a million miles from Earth, peering deeper than any instrument before it. Its purpose was clear: to witness the cosmic dawn, to see the moment when stars were born from darkness, when galaxies first swirled into being. But when Webb looked into the deepest shadows of space, it didn't see innocence. It didn't see simplicity. It saw a paradox. A cosmic impossibility. For decades, scientists thought they understood the early universe's story. It began with the Big Bang, a blinding flash of creation. Then came a long, cold silence, the cosmic dark age, when matter existed, but light had not yet found its voice. Gradually, hydrogen clouds condensed, igniting the first stars. Those stars burned, died, and scattered heavier elements into space. Galaxies formed slowly over billions of years. Complexity, according to the textbooks, was the end of the story, not the beginning. The rule was simple: the further back in time you look, the simpler things get. But when Webb focused on a region of sky so empty it was thought to be cosmic wasteland, it found something that should never have been there: a fully formed galaxy, ancient beyond comprehension. Not a faint smudge, not a disorganized cluster of gas. A sprawling, rotating city of stars. Spiral arms coiled like ribbons of light. Dense clusters moving in perfect harmony. And at the heart, a supermassive black hole, pulling reality itself into a whirlpool of gravity. At first, astronomers thought it must be a fluke. A strange coincidence. A lucky find. But as Webb's data streamed in, the fluke multiplied. More galaxies emerged, each one mature, complex, stable. They weren't struggling into existence, they were thriving. It was as if the cosmic clock had leapt forward billions of years. The early universe wasn't a cradle, it was already a metropolis. And this left scientists with a terrifying question: what if the universe didn't grow the way we thought? What if our entire timeline is wrong? Let's put this in perspective. This particular galaxy existed just 400 million years after the Big Bang. In cosmic terms, that's like finding an ancient redwood tree a week after planting the seed. The expected picture of such a young galaxy should have been messy: loose clouds of hydrogen, chaotic collisions, stars barely forming. But Webb's image was a work of architectural elegance. Spiral arms stretched for tens of thousands of light years. Its central core pulsed with organized energy. Star clusters orbited in patterns so stable, they looked like they had been evolving for eons. The most unsettling part? The galaxy was chemically mature. When Webb spectrometers, devices that break light apart into its chemical fingerprints, analyzed these galaxies, they found elements that had no business being there. Oxygen, carbon, even iron. You see, these aren't primordial elements. They're not born in the Big Bang. They're forged in the hearts of massive stars, then scattered into space when those stars explode as supernovae. That process doesn't happen instantly. It takes time. First-generation stars burn hydrogen and helium. Then they die. Their remains form new stars enriched with heavier elements. This cycle, in theory, takes hundreds of millions, sometimes billions, of years to play out. Yet here were galaxies less than 400 million years old, containing the fingerprints of multiple generations of stars. This means not only had the first stars formed and died, the cycle had already repeated more than once. The early universe wasn't quietly waking up. It was running a marathon at full sprint. And then came the black hole. At the core of one of these galaxies, Webb detected a gravitational monster. A supermassive black hole over 1 billion times the mass of our Sun. That's staggering in today's universe, but in the early cosmos? It's cosmologically absurd. Black holes, according to current physics, start small, the corpses of massive stars. They grow slowly, feeding on gas, dust, and stars over billions of years. Even with the most optimistic models, non-stop feeding, accelerated growth, such a giant shouldn't exist this early. It would be like finding a fully grown adult, born just an hour ago. The math doesn't work. And yet, there it was. Some researchers now propose primordial black holes, objects that formed not from dying stars, but directly from extreme density pockets moments after the Big Bang. Others whisper about exotic physics, dark matter shaping the early universe like an invisible scaffold, speeding up everything. But these aren't tweaks to the theory. They're revolutions. And the strangeness didn't stop there. Webb began revealing patterns in the distribution of galaxies, not random scattering, but ratios and spirals eerily similar to the golden spiral found in shells, hurricanes, and sunflower seeds. A fractal geometry, woven into the very architecture of the cosmos. If this was coincidence, it was one so vast it defies probability. The idea that the same mathematical harmony guiding the growth of plants and storms on Earth could be mirrored on a galactic scale is unsettling. It hints that perhaps the universe was coded from the start, not chaos but design. Design by what? Or by who? Then came the most disturbing chemical find. In a region of interstellar space so ancient it was thought to be utterly sterile, Webb detected complex organic molecules. Not simple methane or ammonia, but polycyclic aromatic hydrocarbons, the building blocks of amino acids, and therefore, life. These weren't clinging to planets or locked in comets. They were drifting freely, intact for over 13 billion years. If this is correct, life's ingredients didn't arrive late in the cosmic game. They were present almost immediately, not as a rare accident of planetary chemistry, but as a constant, seeded into the universe's fabric from the beginning. That would mean life is not an exception. It's the rule. But perhaps the most haunting image Webb has sent back is known simply as the flower. 6 galaxies orbiting a central object, positioned like the petals of a perfect blossom. Their distances, angles, and rotations aligned with such precision that no natural model can reproduce it. Some scientists blamed gravitational lensing, the bending of light by intervening mass. Others proposed relics of quantum turbulence from the early universe. But some dared to consider a third option, that it was a marker. A signature. Something placed in plain sight, meant to be seen only once a civilization had the technology to notice it. And then, a chilling theory began to circulate, one that sounds more like science fiction than science. The observer effect in quantum physics tells us that the act of observation can change the outcome of an event. It's been demonstrated with particles. But what if this principle operates on the scale of galaxies? What if, by looking this deeply into the universe, we've changed it? Some Webb data appears to shift subtly depending on when and how it's processed. As if the universe is not just a stage, but a living script that rewrites itself in response to attention. If that's true, we're not simply explorers. We are participants, co-authors, of reality itself. James Webb hasn't just expanded our view. It's expanded our role. The telescope has shown us galaxies that shouldn't exist, chemistry that shouldn't be possible, patterns too perfect to be random, and signals that feel aware. Maybe the universe isn't silent. Maybe it never was. Perhaps, for the first time, the cosmos has whispered back, not in words but in light. In patterns. In echoes that cross billions of years to reach us now. Maybe we didn't find the edge of the universe. Maybe we found its memory. And maybe, it remembered us. So the question is no longer, what did Webb see? The real question is, what saw Webb? If this left you shaken, if the patterns seemed too deliberate, the timing too perfect, the revelations too synchronized, you're not alone. Because we may not just be watching the stars anymore. We may be watching the response.